Okay, so we were talking about the binomial distribution yesterday. We ended up with one example on the binomial distribution where we had an idea of what is the probability of success, number of trials, and so on. Today we will solve some more examples, but before that, I will discuss the mean and the variance for binomial distribution. Okay, so this is going to happen for every distribution, every probability model. So right now, binomial distribution, uh, recall. So x is a variable which follows the binomial distribution with the parameters. What are the parameters? Number of trials and probability of success as p. Now, in this case, the probability of capital X equal to small x is denoted by capital P of x. This will be given by n c x p raised to x q raised to n minus x. This is the probability uh, mass function when x is a discrete random variable and when x is between 0 and n, then the probability will be given by this, and otherwise it is 0. Now my question is, how can we give the mean for this distribution? Yes. How do you define the mean for a random variable? You have seen this. Why you are acting that you haven't listened this term of that mean for a random variable? How do you find the mean for a random variable? No one. Look, if this is the case, then I won't give any explanation. I'll directly write down the formula. Okay, fine, as you wish. So the mean is n into p, and the variance of the binomial distribution, the variance of of binomial distribution is equal to n p q, and standard deviation of binomial distribution is under root n p q. Now example, on an average, on an average, a box containing 10 articles is likely to have two defectives. Is likely to have two defectives. If we consider a consignment of 100 boxes, if we consider a consignment of 100 boxes, how many of them are expected to have 3 or less defectives? How many of them are expected to have 3 or less defectives? What are the number of trials?
3.
3. Sure. Number of trials is 3.
100.
100 is the total. I mean, the
Sorry.
constraint is of 100
10,
boxes.
10, 10, 10.
Aditya, what we are going to do is the probability of success. What is the success here? We need the probability of the defective. As we need the probability of defective, we will consider the defective as my success, right?
Yes, sir.
Yeah. So the probability I can calculate is for just one box. By the data given, there are 10 articles, and is likely to have 2 defectives. It means that we are able to find the probability. So number of trials, n is equal to 10. What is the probability of success?
One by five.
1 by 5. So first of all, my random variable, what it is going to calculate, x is the number of defectives. Number of defectives. So the probability of success is 2 by 10, which means that 2 by 10, which is nothing but 1 by 5. And so the probability of failure is going to be 1 minus 1 by 5. So this gives me q is equal to 4 by 5. Now what do we need? We have a consignment of 100 boxes. So if in one box my probability of getting 3 or less defective is 0.83, then out of 100 boxes, how many are going to have 3 or less defectives? If in one box the probability of getting 3 or less defectives is 0.83, I'm saying consider. If this is the probability, that probability of x less than or equal to 3 is this, then how many boxes out of 100 are going to have 3 or less defectives?
83.
83. So what we are going to do is we are going to simply multiply by 100. So there can be many examples of this type where you have a certain probability that you can calculate for one particular unit, and then out of a large consignment we will be able to give the number of boxes with the required probability of success. Fine. So to find probability of x less than or equal to 3, so we'll have probability of x less than or equal to 3 is equal to probability of x equal to 0 probability of x equal to 1 plus probability of x equal to 2 you can directly put this in your calculator, summation 10 cx p raised to x. What is our p? 1 by 5 raised to x and 4 by 5 raised to 10 minus x. X is running from 0 to 3. What is the probability? Look, it is, the choice is yours. I mean, you can find it for each and every term, but there is another way of doing it. As I said earlier, you enter this function. Which one? Just this function in your calci. Once you enter that function, then press calculate. Once you press calculate, give x equal to 0, write down the term, give x equal to 1, write down the term, give x equal to 2, write down the term. If you don't want to use the summation, give me the final answer. is be quick. Aditya, Manas,
So 1 minute. It's a calculating.
Auroshri,
Yes, sir. Doing so. So is it around 0.87 or 88?
yes, exactly.
Okay.
So it is 0.8791. 0.8791. Look, you will have to understand your calculators to do this, or else at the time of exam you will face a lot of difficulties. So now, out of consignment of 100 boxes, 100 boxes, 0.8791 into 100. So that is nearly equal to 88 boxes. Will have less than or equal to 3 defectives. Will have less than or equal to 3 defectives. Less than or equal to 3 defectives. Next example. The mean and variance of binomial distribution. The mean and variance are 6 and 2 respectively. Find probability of x greater than or equal to 1. Yes, how can you deal with this now?
Sir, NP is 6 and NPQ is 2, so we can find the probability of failure and then probability of success and then total number of trials.
So NP is 6 exactly, and NPQ is equal to 2. So if we substitute this NP in this, so we'll have 6 into Q is equal to 2, which gives me Q is equal to 1 by 3. Also with this, P is going to be 1 minus 1 by 3. So P is equal to 2 by 3. Substituting this value 2 by 3 in this, so n will be equal to, hence n is equal to, if we put this 2 by 3, n is equal to 9, right? So we have all the required things now. Find out the probability of x greater than or equal to 1. How can I find out the probability of x greater than or equal to 1? Should I go from 1 to 9?
0 and 1 of a failure.
0 and 1 of failure. Didn't understand.
If the probability of failure is 1 and 3, na, so we can find probability of less than or equal to 1.
Huh? What is the total probability for all the random variables if I consider? How many random variables? I mean, what is the range set of random variable over here? That will be 0, 1, 2, up to 9. So all the probability is distributed between these values. So I can take this as 1 minus probability of x less than 1, which is 1 minus probability of x equal to 0, which is 1 minus 9 c 0 p raised to 0 q raised to 9 minus 0, which means that 9. So this is 1 minus 9c0 is simply 1, q is 1 by 3 raised to 9. What is the answer?
Sir, 0.99.
0.99. So now our approach is always going to be the same. I mean to say that in every of the probability model or probability distribution, what I am going to do is, or we are going to do is, we will write down the probability mass function for the certain distribution. Once the probability mass function changes, your distribution changes. Okay, so but because if you look at probability mass function, what is it? It is simply the way your probability is distributed over the range set of your random variable. Okay, so in each of the probability model, what I will do is I will write down the probability mass function. uh, Depending on that function, what are the characteristic under which our data will follow a particular distribution, and we'll solve 2 to 3 examples. Also, we will see what is the mean and the standard deviation for the given probability mass function or the probability model, and that's how our probability will end. Fine. So I will start with the new probability model, which is the nothing but the Poisson distribution. So in Poisson distribution, it is again the distribution in which we just have the two cases, that is either there is a success or there is going to be a failure. But what makes this distribution different from binomial distribution? Because if you look at this, then both of them are almost same. I mean, even in binomial distribution, I said that there are only two cases, either success or there is a failure. Again, here I am saying that uh, both the things are same. By both the things, I mean, even in Poisson, we have success and failure. But the major difference is the number of trials and the probability of success. In Poisson, the Poisson distribution is well fit when their number of trials are very large. If you look at the previous examples in binomial distribution, our number of trials were small. Probability of success was not very much less. I mean, both the probability of success and failure were almost comparable. But in Poisson distribution, what happens is the number of trials is very large, and P, the probability of success, is very small. Probability of success is very small, and number of trials is very large. So it is considered as the limiting case of the binomial distribution, because as you make the number of trials large, it means that n is tending to infinity, and also you can see that the probability of success is very small, which means that p tends to 0. So this means that when we take these limits on the binomial distribution, we will get the probability Poisson distribution, and that's why the Poisson distribution is also called the limiting case of the binomial distribution. Okay, in this distribution, particularly the Poisson distribution, the probability mass function, or probability of r successes in a series of trial, in a series of large number of trials n, with p as the probability of success. With small p, the probability of success. The probability of success at each trial. A small number is given by the probability of x equal to r successes is given by z raised to r into e raised to minus z upon r factorial. So this will be for 0 less than or equal to r is less than or equal to n, because there are only n number of trials, and after that there is 0 otherwise. There is one small question. What is the question? That what is the term z? Okay, so you need to understand this z, because in some examples you will have to calculate it, and in some example it will be given in such a manner that you will not be able to understand what is that. So z is nothing but the mean. What's the formula for mean in binomial distribution?
NP.
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 N into P.
Yeah. So the value of z will be calculated as n into p if the mean is directly given. The mean of this random variable is this, and then we can uh, directly take this as z, which is also equal to the variance. So the standard deviation for the Poisson distribution is going to be under root np, which is equal to under root z. I am again repeating one statement. What is the statement? That when you have a data, our task is to identify which of the distribution fits best to my data. Okay. So just like you decide a sampling, I mean, what is the objective of your study? You define, you according to the objective, you decide which sampling method I can use. Like for an example, if you go to a shop to buy wheat, then you just take a handful of wheat and you look at it and you decide. So that is a technique, sampling technique, that you decide which is best suited for your purpose, right? In the similar manner, in the probability distribution also, we have different probability distributions. Depending on our situation, we decide that which is best suited for this given data. And how do you decide which probability distribution is going to be best suited? So that is this things that I am writing earlier. So for binomial, uh, number of trials is less, there are only two choices, success or failure, then I'll go for binomial. If the probability of success is very small and the probability of success is very small and number of trials is very large, in that case what I'm going to do is I will go for the Poisson distribution. So again after this we'll see another distributions. So we'll repeat the same statement once again so that this you understand the reason by why we are studying so many different probability distribution. Example: average number of misprints, average number of misprints per page of a book is 1.5. assuming the distribution of number of misprints follow Poisson, then find first one, probability that a book is free from misprints, is free from misprints. Number of pages containing more than one misprint, containing more than one misprint. If book contains 900 pages, if book contains 900 pages, yes, what is given, what is to be found? What is given? Given is the value of z,
Z.
which is 1.5. What is to be found? In the first case, probability of x equal to 0.
0.
And the other one, probability of x containing more than one misprint, number of pages containing more than one misprint. So probability of x strictly greater than 1. So since x follows Poisson distribution, if x follows Poisson distribution, follows Poisson distribution. So probability of capital X is equal to small x is given by e to the power minus z raised to x upon x factorial. This is the formula that we have, right? So probability of x equal to 0 will give me probability of x equal to 0 is equal to e to the power minus 1.5 into 1.5 raised to 0 divided by 0 factorial. What is the answer?
Sir, 0.223.
0.223. And probability of x greater than 1 is equal to this will be
1 minus probability of x is equal to
x equal to
0.
look, you are finding out the probability of x greater than 1. This is 1. You need probability of this, which means that I need the 1 minus probability of everything less than this. 1 will be included because 1 is not included in this. So, which is 1 minus probability of x equal to 0 minus probability of x equal to 1. Either you can use the summation or you find both the values, enter the formula in your calculator. So 1 minus e to the power minus 1.5, 1.5 raised to 0 upon 0 factorial minus e to the power minus 1.5 into 1.5 raised to 1 upon 1 factorial. What is the answer?
Sir, 0.442.
0.442. So it was said that there are 900 pages in the book. So number of pages containing more than one misprint. So what we'll have to do? We'll have to multiply by 900. So the number of pages with more than one misprint 0.442 into 900. It is approximately equal to
398.
398 pages.